The 35-engine SpaceX Starship booster beast is coming. Will booster 18 be the first V3? Did we somehow skip V2? A new test article is getting ready for some crushing tests. Will we see the new Can Crusher 2.0 in action soon? The final piece of the puzzle for the brand new flame diverter has been delivered, and we answer the second part of the question, is China winning against NASA? My name is Felix, welcome to What About It, let's dive right in. Starship updates. The final piece of SpaceX's new Starship flame diverter is in. A new crown for the king of flame diverters. This giant steel construction came to the launch site on Tuesday morning. Its green pipe connector is a clear indication what this is for. It is the top wedge for the flame diverter in Pad B's flame trench. Nice. Once installed, it completes this very important piece of equipment designed to divert the heat and acoustic energy away from the launch structure. It is a key element in ensuring rapid reusability and should help to keep refurbishment work at a minimum in between launches by protecting the launch hardware. I have to say this again, SpaceX's speed is unprecedented. If this continues without hiccups, we might see active tests of this in a few weeks. And the test hardware for this is being made as you watch this episode. Let's talk boosters. Did we get it all wrong? Are we already seeing the end of the V2 booster generation? A debate has started among space fans after a post on X claimed to have spotted evidence of the next booster generation being V3. Wait, did we somehow miss V2? How? One theory claims that booster 4 was already the last V1 as it was the last booster with 29 Raptor engines before that number was raised from 29 to 33. This was also a shift in the engine arrangement from the old 1-8-20 to the 3-10-20 we know today. With booster 17 having returned to the build site after its cryoproofing test, being ready for its 33 engines to be installed, it is widely accepted that this is the last booster of its generation. Boosters from 18 on out will likely see the new 35 engine arrangement with a 5-10-20 configuration. But what should we call this new generation? Is this truly V3? Or maybe simply a Block 2? It could be both. V3 can be Block 2 at the same time, there is nothing wrong with that. And no matter how much we speculate, we will not know anything before we see an official post or article with the correct nomenclature or hear about it in an interview or presentation. Nothing to worry here, it's all just names, they can change over time. And how is this all connected to the launch mount? Simple. The new mount will very likely be purpose-built for the new booster generation. Pad B will launch V3 boosters. One thing will never change. There is a lot going on at Starbase both day and night. And while there is no sign of an imminent launch, the construction and testing of ships and boosters keeps going on fast. A new test article has been spotted. This new aft section test tank, also known as TT-17, was spotted outside at the build site. This test tank is deemed to be the first Block 2 test article, and it will likely see an interesting test campaign over at Massey's. For months now, we have followed the construction of the new generation Can Crusher at the test site. It is a huge contraption made for one thing and one thing only. It wants to inflict pressure on that bold new prototype. If it was green, I'd be tempted to say Hulk smash. But fortunately, it is painted in a cheerful SpaceX gray. Nonetheless, it is a true giant and looks like it can dish out quite some force to push the test tank to its limits. Testing is not only performed at the Massey's test site. When it comes to engine testing, SpaceX relies on its rocket development and test facility in McGregor, Texas. And last week, McGregor was riding the Raptor. With dozens of Raptor tests, some lasting over 4 minutes, it is clear that something big is going on here. Are these the new V3 Raptors getting ready to propel the Block 2 boosters in the not so distant future? The V3 Raptor is a beast in its own right. It's a visual stunner with what is likely the cleanest looking rocket engine design ever. But it has so much more to offer than a gorgeous design. Here's a quick comparison of the 3 generations of Raptor engines. It is fascinating to see how the engineers managed to bring the thrust up while bringing the weight down with each iteration. Just think of the 33 V2 Raptors on the current boosters compared to the V3 35 Raptors on the coming new generation of boosters. The weight of 33 V2 Raptors is 53,790 kilograms for a total thrust of 7,590 tons. 53,000, that is very heavy. 35 V3s weigh in at 53,375 kilograms and deliver a jaw-dropping 9,800 tons of thrust. Yes, 35 V3s are 415 kilograms lighter than the 33 V2s, but more importantly, at the same time they deliver 2,210 tons of added thrust. If testing on the Block 2 test tank goes well, we can expect to soon see Booster 18, equipped with V3 Raptors, rising to usher in a new era at Starbase. We know how fast things can move at SpaceX, with Booster 17 having to wait for Flight 12 or even longer if more boosters are being reused. It could become one of those unlucky prototypes never to see action. Yes, this did happen before on boosters 3, 4, 5, 8 and ships 16, 20, 21, 22, 26, 27 and 32. All those never flew. Innovation sometimes simply runs faster than the test campaign, and sometimes things just need to be built to find out that this wasn't the right idea. We've seen it before and we'll see it again. And there is one more element out at the launch site that is also getting outdated fast. I'm talking about the OG OLM at Pad A, the one launch mount that started it all. With Pad B in Texas and the new pad in Florida both following the same updated construction plan, Pad A is starting to look a bit awkward. I mean, not that it always looked awkward. And when you consider how much refurbishment it needs after every launch while being hard to reach due to its unique stilt design, it has become quite clear that this is not the way to go if you plan for rapid reusability. So it is safe to say once Pad B has been tested and approved, time will run out for the first version of OLM. It may fade away just like the Block 1 boosters it was designed and built for. But that is still at least a few months out. We'll at least see one more launch from this pad. Meanwhile, both Mechazillas are practicing their dance routines. Or to say it less poetically, both sets of chopsticks on Tower A and Tower B saw a lot of testing recently. It looked like the SpaceX team performed a series of virtual catch testing. It could hint at future double catch events when one tower catches a booster and the other one catches a ship. Among other things to come, that is one I personally can't wait for. Of course, there are more rockets out there than the ones you can see at Starbase, but there is no other place where you can get the views that are so up close and absolutely stunning. Check out redlineheli.com/Felix for a once-in-a-lifetime experience and $25 off flying in a helicopter above Starbase. The Redline helicopter team is waiting for you. They'll show you the same views our photographers get on their Starbase flights. Give it a try. On yesterday's episode, we took a look at China's ambitions to be the leader in the new space race. If you haven't seen that episode, it might even make sense to watch that first and then return here and keep watching. China aims to put humans back on the moon by 2029, and its commercial launch providers could well become part of this effort. So today we take a look at those to complete the answer if the US can beat China in building a permanent settlement on the moon. Are they competition for SpaceX's Starship and the Artemis program at large? China traditionally relied on the state-run China Aerospace Science and Technology Corporation, or CASC for short, and its subsidiaries like the China Academy of Launch Vehicle Technology, or CALT. But they have since shifted to allow private companies to become active in the field of civilian and military space launch vehicle manufacturing. One of these private launch service providers is iSpace. It is important to note that they should not be confused with the Japanese iSpace Inc., the company behind the Hakuto moon landers. The full name of China's iSpace is a mouthful: Interstellar Glory Aerospace Science and Technology Company. On July 25, 2019, they lived up to their name and became the first private Chinese company to reach Earth orbit. Their SQX-1, or Hyperbola-1, is a small, solid-fuel carrier rocket with a rather uncommon 4-stage setup capable of reaching low Earth orbit and sun-synchronous orbit. It has a length of 24 meters at a 1.4 meter diameter and a liftoff mass of 42 metric tons. For the fairing, iSpace offers two options. A 1.4 meter fairing with a carrying capacity of 320 kilograms and a larger one with a diameter of 1.6 meters and a slightly reduced payload capacity of 300 kilograms. While the first start from the Jichuan Satellite Launch Center was a success, iSpace has since learned that space is hard, with a track record of 3 successes to 4 failures so far on this rocket. Glorious booms. But iSpace has shifted toward bigger projects already. Meet the SQX-2Y or Hyperbola 2. This is their verification rocket for their first step toward a reusable launch system. This is a small rocket with big intentions. At a height of 17 meters and a diameter of 3.35 meters, it weighs 11.4 metric tons when fully loaded, with 2,680 kilograms of liquid oxygen and 1,156 kilograms of methane. The propellant is fed to a single JD1 engine. It offers a thrust of 13 tons with a specific impulse of 280 seconds. JD1 is also called the Focus series, and its focus is set for reusability. According to iSpace, the target for it is no less than 30 flights. On November 2nd, 2023, SQX-2Y completed the first full-sized first-stage vertical takeoff and landing flight test in China. After proving these capabilities, the rocket was reflown on December 10th, just a month later. This marked the first launch of a reusable rocket booster in China. If these pictures remind you of the flights of Starhopper and the first Starship prototypes, you are on the right track. Based on these achievements, iSpace now seeks to establish itself as a launch service provider in the Falcon 9 class with its SQX-3 or Hyperbola 3 rocket. Its specifications read a lot like Falcon 9. It has a length of 69.6 meters with a core diameter of 4.2 meters and a takeoff mass of 491 tons. It sports a 4.2 meter fairing ready to transport 8.5 tons into low Earth orbit when the first stage is set for recovery. As a second option, the first stage can be expanded, upping the capacity to 14 tons. On the business end of the rocket, you can find 9 JD2 or Focus 2 engines. Again, very similar to Falcon 9. This engine is designed to survive at least 30 launches as well. The SQX-3 is slated to see its maiden launch this year. The milestone of a successful recovery is also set for 2025, with the launch of the first reused rocket in 2026. This timeframe very much confirms the project's ambition. In reality, it will likely take them longer. Many, including SpaceX, struggled and still struggle to achieve reuse quickly. A lot has to go right for this to happen repeatedly. In their demonstration video, iSpace hints at variants of the Hyperbola 3 that look very familiar. A bundle of 3 cores could be used to create a super heavy lift vehicle similar to the Falcon Heavy. Another very interesting part of the video shows a spaceplane that could be launched on top of a Hyperbola 3 and then return to Earth, landing on a runway like a plane. One thing we did already see is that our channel metrics show over 4 million returning monthly viewers who have not subscribed yet. Help improve the channel and double check that you've hit the subscribe button to stay up to date with our updates. Like this video if you appreciate the content and become a wise supporter for extra content. Secure your access to up to 7 picture galleries per week, satellite, aerial and ground photos and 3D animations, chat with me and gain more insights on the topic you love. The entire team is waiting for you, you rock! We're waiting! Let's move on to another promising Chinese private space startup, Landspace. This company was founded in 2015 and already has one important claim to fame for a feat accomplished with its ZQ-2 rocket. This vehicle became the world's first methane-fueled launch vehicle to orbit, beating SpaceX's Starship, which still needs to become an orbital rocket. The 47.3 meter tall 2-stage rocket has a diameter of 3.35 meters. It has a takeoff mass of 220 tons and can deliver 6 tons to low Earth orbit. The rocket's 282 tons of takeoff thrust are delivered by 4 TQ-12A engines with a total thrust of 720 kilonewtons. In comparison, that's roughly 10% of what a Falcon 9 delivers at liftoff. So far, the ZQ-2 has had 3 successful flights following an initial failure during the first launch attempt. That's pretty much normal. But just as its competitor iSpace, Landspace is already working on the next big thing, and they do so at an awe-inspiring pace. On September 11th, 2024, their brand new ZQ-3 mastered its first vertical takeoff and landing test. More hoppy vibes here. The test flight reached a maximum height of over 10 kilometers and lasted approximately 200 seconds. So that's not a small hop. Around 113 seconds after liftoff, at an altitude of roughly 4,640 meters, a mid-air engine cutoff test was conducted, followed by an engine reignition test approximately 40 seconds later. That is pretty cool. ZQ-3's development is in full swing, and more details are leaking out, showing promising progress. Once operational, this two-stage medium to heavy lift launch vehicle made of stainless steel aims to become a reusable option for China's spaceflight needs. With all testing so far involving early prototypes and test articles, the maiden launch of the Zhuque 3 is expected for the third quarter of 2025. So just around the corner. The rocket will eventually have a liftoff weight of approximately 660 tons, measuring 76.6 meters in length and 4.5 meters in diameter. That's big. It will be able to carry a payload of up to 21 tons to low Earth orbit in expandable mode, 18.3 tons when the first stage is recovered downrange, and 12.9 tons when the first stage returns to the launch site. After successful testing, the Zhuque 3 is expected to enter commercial operations in 2025. Launching the Haolong cargo space shuttle for a resupply mission to the Tiangong space station. That sounds pretty advanced. While Landspace and iSpace might be the more advanced companies in the Chinese private space industry, there are a lot more competitors here. At the moment, there are more than 400 companies in this sector in China. While most of them are suppliers, only a few are developing their own launch vehicles. Noteworthy among the latter are Galactic Energy with its small 19-meter 4-stage Ceres-1 rocket operating successfully since 2020. The next product in development is a 2-stage medium-lift orbital launch vehicle, currently in development with a launch expected in the next few months. Get it? All of these dates are, like, right around the corner. Next up is Deep Blue Aerospace with their Nebula family of rockets. Their Nebula 1 has already performed a 100-meter level launch and landing test with a Nebula M1 VTVL, or vertical takeoff and landing test stage. The first orbital launch and recovery of the Nebula 1 rocket is planned for mid-2025. There is a pattern to this. Instead of copying the drone ship concept, Deep Blue Aerospace plans to use offshore platforms for the rocket's landings. Nebula 2, a heavy-lift liquid-fueled rocket powered by liquid oxygen and kerosene, is capable of lifting 20,000 kilograms of payload into LEO and is still expected to debut in 2025. While Deep Blue plans to land on water, Orion Space has converted a barge to be their launch platform. It is located in the offshore waters of the Haiyang port and will be utilized for their Gravity rockets. Gravity 1 is a solid propellant medium-lift launch vehicle that can be used for deploying large-scale satellite constellations. Its maiden flight was conducted on January 11, 2024, breaking records as both the world's largest solid fuel carrier rocket and China's most powerful commercial launch vehicle to date. And maybe for being the most destructive rocket for a ship-based launch ever. Super fun to watch. For 2025, the company plans to launch Gravity 2, a partially recoverable 60-meter tall heavy-lift launch vehicle. It will also serve as the base for the planned Gravity 3M, a heavy-lift variant using 2 Gravity 2 cores. And there are still more rocket manufacturers active in China, such as Link Space or OneSpace. I'm sure we'll take a look at them in the future. With all this development in the Chinese space sector, it is safe to say that China is not that far behind as many in the traditional spacefaring countries would like to think. It's almost on par with what we do here. China's gaze is firmly pointed at space, and the moon is coming into reach fast. It won't take long for China's private players to provide supporting services to their national space agency. In much the same way we have seen in the US launch market, it is pretty obvious that national missions will soon also rely on such service providers. With that much know-how and innovation rising, the 2029 goal for a Chinese crewed moon mission looks realistic. Now it's up to NASA and its suppliers to show who will be the next to set foot on our nearest neighbor. That's it for today. Before watching the bloopers, remember to smash that like button. Subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our one-of-a-kind Raptor shirt and a new Mechazilla fan club shirt, which I am finally wearing as well, are both up. Link is in the description and in the card you should see now. Also, check out our print store at shop.whataboutit.space to buy a picture for your favorite wall. A significant amount of every purchase goes directly to our photographer Jordan. And if you want to learn about SpaceX's Raptor engine and how it's revolutionizing spaceflight, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again on the next episode. Of the puzzle, the piece of the puzzle needs to become the vehicle. Stars keep going fast. Or element out.